Hello, 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 and a very good afternoon. Hi, everyone. I'm Cheryl from Cytron-rero EDUteam. I am your host for this afternoon, and I'd like to wish everyone Happy Pi Day. Yes, March 14 is the International Pi Day, and we have something special for all our viewers this afternoon. We have for you Introduction to Python Programming using EDU PICO. Oi, can you see? Oops, the filter. Okay, so this is our latest product from Cytron Technologies, and we designed it especially for you, teachers, and also students who are exploring, who are interested to learn Python programming. So the whole idea for this kit is to make Python and physical computing, how do I put it? Beginner friendly and fun for everyone. So this afternoon, we are going to do the unboxing, and straight away we will do hands-on coding with Tony IDE. Okay, so if you are ready, let's start. These are the requirements for this afternoon session. So it's a hands-on session. And if you are watching me, I think you should have internet access and your computer ready. And we also like to invite everyone, if you haven't yet, maybe this is a good time for you to install Tony IDE. Okay, you can download the software for free from tony.org. We share the link in the live chat as well. You can click, download, and have it installed, and then you're ready to go later on when our presenters show you how to go about it programming EduPico. And of course, if you have your EduPico with you, you can have it ready. Okay, get out the EduPico board as well as the USB cable. Okay, just a gentle reminder for all our viewers here today, this afternoon. We have an international crowd with us today. I think I saw some just now from Singapore. From where else? Let me see. Oh, from Indonesia, from Pakistan. Wow, wow, wow. Thank you for joining us. Wow. Okay, and not forgetting our Malaysian teachers as well. Okay, so for during the session later on, if you have any doubts or any questions at all, please feel free to drop your comment in the live chat, and we will answer from time to time. And also we'll have a Q&A session at the end. Okay, so hang around with us. And also, please take note that eCert will only be issued for participants who join live, okay, for the next 2 hours. And the link will only be shared at the end of the session, okay? So stay till the end, fill out the attendance and feedback form for the eCert. And a special note for MOE teachers. So these are teachers teaching in Malaysia. If you need your attendance to be registered in the SPLKPM system, okay, Malaysian teachers will know. So for our guests from outside Malaysia, this is our local professional development system for our Malaysian teachers. So if Malaysian teachers, if you need your attendance to be recorded in the system, please remember to fill out the form for SPLKPM as well, okay? And please double check and make sure you enter the correct IC number, okay? Please double check so that we can record it correctly in the system. And for everyone's information, this webinar is a joint effort, is a collaboration between Cytron Technologies and Johor State Education Department, Sektor Pembelajaran. So a special thanks to JPN Johor officers for supporting this initiative for us to bring EduPico, to bring Python programming to even more teachers so that everyone can get hands-on, everyone can be well prepared to introduce Python to our students. So without further ado, I would like to invite our presenters, our trainers for this afternoon to join me here in StreamYard broadcast. So can I invite Adrian and Ifa? Okay, so for your information,
Hi.
EDU PICO here is Adrian's brainchild, is his baby. He has been spending the last few months working very hard to put this together. Of course, not Adrian alone. He worked very closely with the design team, design engineers in Cytron, and our designer as well. If you have the book, I'm sure you agree with me that the designs are just awesome, right? They put in a lot of hard work, a lot of effort into this. So let's see. Adrian, Ifa, are you ready?
I'm ready.
Yes, we are ready.
Yeah.
Yes.
Okay. Over to you then.
Thanks, Cheryl.
Thank you, Cheryl. All right. Good afternoon, everyone. Thank you for making the time to join us on this Pi Day. Today, we will be introducing to you EDU PICO, as well as how you can start Python programming using EDU PICO. But before that, let me quickly introduce over here. We have Ifa. Right? Ifa is the video content creator for EDU PICO, and I'm Adrian. I'm here today to share with you on the module and also the EDU PICO board, the functions of it, and hopefully we will be able to cover as much as we can. Okay, we have 2 hours, and let's make the full use of it. All right? Okay, let's go. Are we lagging? Okay, so over here, okay, we have this EDU PICO. I hope everyone can see us, can see the screen well. I hope the line is well as well. Okay. So we have this EDU PICO here today, EDU PICO here. If you have your set with us, I encourage you to go through the whole thing with us. Yeah, together. And if no, it's okay. This session is recorded. You can always rewatch this session as well. So EDU PICO, the book, this is not an A4 size, right? But if you happen to know about EDUBit, the design of the box and everything, the size of it is similar to EDUBit as well. Okay, this is the nice handheld size. Okay, it doesn't weigh much at all. So over here, we can see that the design, our standard design, code, play, and learn, this is our model. And then all the features put in the form of logos are stated here. Okay, what are the components provided and the features provided inside the EDU PICO. Okay, and then over here, code, play, and learn. And here, explore STEM encoding with EDU PICO. Okay, so back to the front design. So you will see that the board, okay, a very nice touch from our designer, Suhana. So she designed the entire box insert, including the book as well. So this board, EDU PICO, is powered by the Raspberry Pi Pico. That's why we got the name EDU PICO. Funny. Hi, welcome everyone. All right, thanks for coming in. We have just started, so it's okay, it's still early. So the set is for age 12 and above. And then at the back here, what's in the box? Okay, inside we have this EDU PICO board, step-by-step guidebook, a textbook, and then we have some accessories to come along with the projects when you learn Python. Okay, whenever we talk about learning Python, it's always about software. When you hear about Python programming, the first impression that we have is programming. Okay. Today, what we want to introduce to you is how you can make your class exciting by introducing hardware while learning Python. Okay. That idea is no longer a dream, right? It's actually happening right now, and people are actually learning Python with the support of hardware. Okay, let's go ahead and open this EDU PICO. Okay, so when you open the box, you are welcome with the EDU PICO guidebook. Okay, and then the guidebook will look like this. The thickness is about this, a total of 186 pages. Okay, designed for students, for teachers to conduct their Python classes with the hardware and accessories available inside this box. So we have a few accessories here. We're gonna go through it later on as we touch the chapters. Right? There are a lot, and I'm not gonna go through every single one of it yet. I'm gonna leave it aside. And here we have our EDU PICO board sitting in the middle of the box here. Okay, you can take it out like that. Okay, and then you have an image of EDU PICO in here as well. And then on the other side of the box, you have the label, the features, the components on the EDU PICO. So it fits perfectly for you to directly self-exploratory. You can see directly, okay, what is what on the EDU PICO board. Okay. And down here, we have this table of content up to 8 chapters. 8 chapters from the book. And here we have our resource hub QR code. Okay, QR code here. So this, you can go to edupico-hub.cytron.io. You can have access to all the chapters available on the book, but through the website. So if you don't have the hardware today, it's okay, right? It's completely fine. Later, when you install the software, you can go through it with us for a few chapters. But later on, the harder chapter, you may need the hardware. But what I'm saying is that you can have access to the book right now immediately. Let me drop you the link in the chat right now very quickly. So you can have access to the book, to the website, as we go along throughout our lessons. Okay. So down here, we have this little compartment. You open it up, and then this is what you see. Okay. Right. You are not just the accessories, the board. It comes with a few components like the cable, USB micro B cable for you to program your EDU PICO. It comes with servo motor, okay, a single servo motor. Okay, let me do a very quick zoom in so you can see clearer. Okay, servo motor. Yeah. And then we have this USB light stick. Okay, it's a flashlight. Okay, you can ban it, you can use it, but then it's USB lah. It's for one of the project that we'll be doing later, and as well as one bag of small components. So in here we have a screwdriver, we have our groove cables, we have our DC motor. We need to. Okay, we have DC motor. Okay, let me just take it out. Take out some lah, or else it's gonna get messy. We have zip ties. We have velcros for you to stick your components. And then we have our screwdriver, DC motor. Okay, this is non-solderable. You don't have to solder it. And then you have some cables here. Okay. I'm gonna put it aside first. I still see people coming in. Welcome everyone to this introduction to Python and EDU PICO. We are just about to get started. Right now we are introducing to everyone the EDU PICO hardware. We haven't started the Python programming yet. So don't worry, keep it coming in. And then again, feel free to drop your questions as we go through this lesson today. Okay, I think that's it for the box, right, Ifa? Okay, let's put the box at the side. So we have a lot of components inside the EDU PICO box. And to top it off, as we go through our lessons, we are going to refer to the book. So if you don't have the physical book, it's okay. I just dropped the link in the comment section. You can download the book right now, the PDF book, the full book. And then as we go through, we will let you know, hey, let's go through page number what, and then you can refer to the book together with us. Okay? All right. Are you all ready?
Selamat sejahtera, cikgu.
Selamat sejahtera, cikgu. Are you all ready? I'm not sure. Okay, good. Okay, let's get started right now. A very quick introduction. Let's change our screen. Okay. Selamat petang. So in this session, we will experience EDU PICO virtually, and as well as we will introduce you to Python or CircuitPython using the EDU PICO. Okay. To start with this activity, you will first need to have a laptop or a functioning computer. And then you will need to have you need to have good internet connections, and as well as the EDU PICO kit. Okay. So in the book, we will go through 8 different chapters, right? Depending on the time that we have. So that's the goal for today. We have 8 chapters. The first chapter is to program with CircuitPython. We will do a very simple hello EDU PICO code on CircuitPython or on Tony IDE, and as well as to show you how you can install the software easily. And then in chapter 2, we will go through water drinking reminder. But we are not going to work on the project. Instead, we will go through the basic components, what components we need to complete the water drinking reminder. And then chapter 3, we have gesture reaction game. Chapter 4, we have color detection game. Chapter 5, automated waste bin with accessories, which Aoife will be demonstrating on how you can build this accessory to make your project more interactive, more fun, so you can see the effect. Noise pollution monitoring, smart classroom, and climate control greenhouse.
And then all these chapters and projects is SDG, right?
Yes, all these chapters are all aligned with the SDG goals, the Sustainable Development Goals, and it's topped up with a series of comic. So before the students or before you go through each project, you will be welcomed with comics. Okay, you have to go through the comic to understand why you need to build the project before you build the project. In the fun way, right? Using comic. Okay, so let's start with our first chapter, programming with CircuitPython. I hope all of you are ready. Have an EDU PICO with you. Okay, and let's go. So if you have a book, this is how the book works. Okay, as you flip through every different chapters, you will see that the book, every activity will begin with an introduction, a very simple introduction. And in this introduction, there will be graphics to explain to you the outcome of that project or the activity. So that's under how this activity works. So this is to help you have an idea, like if you want to press this button, what's going to happen? Okay, what's going to happen next? If you don't know what's going to happen, you'll be pressing the button, but you are not sure what's going to happen. So this is where it comes in, like explain to you what you should expect. After that, there will be some codes for you to type the code. You can directly copy and paste for the students to directly copy and paste to practice their typing skills, text-based programming skills. And after that, there will be what the code does. So this area, students will go through sections by section of their code. So the code is divided into 4 different sections. How to import your library, how to initialize your components, your pins, how to define functions if there are functions used in that chapter. And of course, there's a continuous loop, what's happening in the continuous loop. So it's divided into these 4 sections. After you finish a project, you see, okay, your button is working, okay, you see your results. You're gonna ask yourself, what to do next, right? What should you do, okay? So there will be this mini activity or what's next session where they will encourage you to take your project to the next level. So what you need to do next, okay, you can press your button. Okay, now you can build a project using that button, okay? And last but not least, we'll have the more you know, it will explain to you how a button works, the breakdown of the component, some fun facts, so that you can share it with your students to make your lesson more interesting. Okay. All right, so this is the flow of a single project. And by the end of the component project, the module project, you will be welcomed with a comic, like what I said earlier, comic. Okay, the comic will eventually bring you to a project. And then you build the project, and then at the end of the session, you will get some challenges and bonuses lah. Okay. So sorry again, I'm moving a bit fast because we can't really see what I'm trying to describe here without the book in front of us. So I'm bringing it through with you lah. But again, I welcome more questions. I think we have one question from the floor, right? Okay, from Lo. So suitable for primary school or not? So this book, this set is designed for age 12 and above. The prerequisite is that students will have to go through some basic programming, example, microbit, make code, or even M-block with Arduino. They have to go through at least all these basics before they move into Python programming, or this may pose as a challenge for them. They will get intimidated by all the text and all the words. So the book is designed for high school in mind, but of course we welcome teachers and students to explore as they progress through their coding journey. Okay. All right. But I do see a lot of primary school teachers here. Welcome on board. And again, this is a good place for you to start exploring Python. Okay, so in chapter 1, page number, okay, early page lah. Page number 11. Okay. In this chapter 1, we will introduce you to how you can connect your EDU PICO, your board, to your PC, and how to communicate with your EDU PICO and how to program your first program. Okay, so in this section, this is what we're going to do. First, connect your EDU PICO to your computer using your micro USB cable. Okay, I'm going to switch my screen very quickly so that you can see more. Let's do this here. Okay, we have our EDU PICO here. Thanks for the question, Faiz. Who did the comic illustration? So cute. Our in-house designer, Suhana, did the comic illustration. Okay, everything from our in-house designer. Okay, once you have your EDU PICO, take out your micro USB cable, Over here, I have mine. The other side connected to my PC. Go ahead and connect it to your EDU PICO, like that. Okay, once you connect it, are we lagging? Anna, are we lagging? Cheryl, are we lagging? Hope we're not lagging. We can solve that now. All good. Okay, thank you. Just to check, make sure everyone is well received from us. Connect your cable. Next step, turn on the switch over here. Just flip the switch down like that. Okay. So once that is done, you will hear a tone, Mario tone from the buzzer. It's like a welcoming to welcome you that this board has power already. It's ready. Okay. So what we are going to do next is we are going to continue with our slides first. I'm going to show you what you need to program your EDU PICO. Okay. So next we will need, we have already managed to turn it on. We will need to install Tony IDE on our computer. Okay, Tony IDE, it's a very user-friendly software, an editor for you to program CircuitPython with your Raspberry Pi Pico W. Oh, the video under me is lagging. Okay. Thanks for notifying. Okay, I'm gonna switch my Wi-Fi later. Alright, thanks for letting me know. I'll remove it first. Okay, as you can see from my screen, download and install Tony IDE on your computer. I'm gonna drop the link for the Tony IDE, and then if you don't have the software yet, go ahead and install it right now. One moment. Okay, Tony IDE. Tidak jelas. Sora. Cannot hear any buzzer sound. we need to on nearer. Okay. The buzzer sound comes from when you turn it on only once. Okay, and only one lah. Okay, I think you can hear good. All right, once you're done with that, okay, I already dropped the link, the Tony link inside the chat. Oh, yeah, lagging. You will be able to access to the Tony IDE over here. Okay. So this is where you can program your EDU PICO by typing your code on this editor. Okay, as simple as that. Which type of Pico W being used? We are using Raspberry Pi Pico W. Raspberry Pi Pico W. Okay. To identify Raspberry Pi Pico W, simply look at this little silver box over here. This is the W Wi-Fi module.
Out the Raspberry Pi Pico?
When it's power on, not recommended. Right? When it's power off, yes, you can remove it. Okay. All right, let's continue. So to run our first program on the Tony IDE, before we do that, we have to form the communication between our Tony IDE with the Raspberry Pi and the EDU PICO. So click the bottom right, you will see local Python, and then select CircuitPython generate. Just click on this. Okay, can you see? Once you click on this, it may be a bit too small on your screen. I hope it's not. You can see clearly. Once you click on this, it will form the communication with your EDU PICO. So you start communicate lah. It's already talking to each other. Okay. And then the next step is you directly put your program in. So here's what I'm gonna write.
Okay.
Something simple. Okay, I'm just gonna print to make sure that to see it's talking to the EDU PICO. Hello, EDU PICO. Okay, can y'all see? Okay, very big for you. So you just click play button, and then you will see at the bottom, hello EDU PICO. This is the response from the EDU PICO. I type the code in Tony IDE. I send the code over to EDU PICO. The EDU PICO ping back. Okay, it reply to me, hello EDU PICO, in the shell console at the bottom here. Okay, this activity is included in chapter 1. One of the activity, the first activity once you set up your EDU PICO. Okay,
Like
I'm
a
going
warm
through.
up. Like a warm up.
Like a warm up, yes, like a warm up for you to check lah, okay or not the communication. So once you manage to get these results, means that you are ready for the activities, more difficult activities inside the EDU PICO. Okay, today I won't go through every single basics of Python. Okay, instead we are going to learn all those basics as we go through the components on the EDU PICO. Okay, all right. So now let's jump ahead to chapter 2, where we will experience our first component on the EDU PICO over here. Would you like to show? Okay, we are going to go through the first component, which is the buttons. Okay, you can see the buttons on the right side here. We have 2 buttons, one yellow, one blue button. Okay.
All
right. So back to the code. So to program our button, okay, we have a question here. Does the message appear on the little LCD color screen on the EDU PICO kit? Yes. The mini LCD, it's called the OLED. It's for us to program and show characters, show words, or even display your sensor values on it. Okay, it's for us to program. It's in one of the chapters. Okay. All right. So in chapter 2, button, this activity on page 29, okay, page 29, what's going to happen is, if we press the button here, let me show again. If we press the button here, the Tony IDE shell console, the output, it's going to tell us that, okay, this button is being pressed. Okay, you are pressing this button. It's as simple as that. I press the button, you tell me you are being pressed. Okay, so let's go through this simple code on page 30 on the EDU PICO book. Page 30. For those who just joined in, do scroll up the comment section. We did drop the link for you to download the book. But if you haven't received that link, again, I will drop you a direct link so that you can go ahead and just download the whole book, the PDF book. Okay, it's open for all. Everyone can go and download it. Okay, because we are going through today's lessons with this EDU PICO module, so it's easier if you can go through the book with us. So in this first activity, I'm going to type the code. Okay. Are you all ready? Hello, everyone. Are you all ready? Great. Okay, I hope you guys are ready. Yeah, ready? If ready, here's what I'm gonna do. Hello, okay, welcome.
Welcome, Jay.
I'm gonna type the code right now on the Tony IDE, okay, by following page number 30. First things first, I'll need to import necessary library that we need to get this project working. So by importing board, import time, and import digital I/O, this allows us to control the delay on time and the input, the pins that we need to use for the buttons, and as well the board to control the entire Raspberry Pi Pico W. So these are the 3 main libraries that we need to program the buttons. Next
is button. We need to input the button.
Input the button to initialize the button.
Yes.
So I'm not going to be creative today. I'm just going to follow the book exactly. Button A equal to digital I/O, digital in, out, and board.gp 0.
What does the GP0 mean?
The GP0 means you will need to connect. Okay, when you look at the buttons over here, as you look at the buttons here, there is a label above here, slightly blur. there's a label up here that says GP0. Okay, that's meant for these buttons here. There's GP1 and GP0. So we are programming the button A, the yellow button here. Okay, this is GP0 and this is GP1. So back to the program. That's why we program it bot GP0 to control the variable called button A. Next, I'm gonna declare this button A as the direction into input. So a button is an input, a passive input, an active input component where you press and then it sends a signal to the EDU PICO. Okay, if it's an output, means it's providing you signal. So right now I'm sending signal to the EDU PICO by pressing the button. So I need to declare it as an input, the direction into input. Okay, and lastly, I will need to do a pull, digital I/O pull out. Okay, this is to ensure that the pins are constantly pulled up. I'm not going to go into detail on this pull up, but then if you're curious, page number 31 explains it all. Okay. Next, while true, which means that the code will run forever under here. When I press enter, it automatically indent for me. Indentation in Python is very important. Okay, without the indentation, it won't know that this code is supposed to run under while true. So that's why you need this indentation over here. And then followed by if not button underscore a dot value. And then print button a is pressed, record and time dot sleep 0.3. So if button A sends a not signal, means it's being pressed, it will print this word and then it will delay for 0.3 seconds. Okay?
Okay.
All right. So that's the end of this code. Okay, a very simple project 1 code, 12 lines for you to control your buttons. Go ahead and press play. Okay, and then in CircuitPython in Tony, as you receive an error, you immediately know because it will tell you, okay, digital is not defined because I have a typo somewhere. Okay, can you spot it? If no, it will tell you it's on the line number 6. Okay, somewhere there is a false spelling. So where do you see it?
Yes.
Do you spot it?
Digital.
Digital.
Nice.
Line number 6, digital. Where do you see it though?
Digital direction. Digital I/O.
Oh, digital I/O. Okay, this is my fault. Okay, so just follow the code exactly the same and then everything will be okay lah. Okay, just now I was typing without looking, so I'm getting more error than I should. Up. Okay, lucky. Ifa is keeping in check. Up. UP, capital letter. And then play. Okay. Thank you, Ifa. Done. So once we play the code, the next part that we need to do is, you already know the expectation, you need to press the button. Press the button to see the effect. So we have our button here, the yellow button. As you press, it's gonna show you button A is pressed, button A is pressed, button A is pressed. That's it. All right. This is the first activity with a little interaction with hardware and software. Okay. All right. I'm gonna take a very short pause because we have a few questions coming in from the comment section. Okay, let's take a look at the questions here. can I play MP3 audio or stream audio in Pico W? And the second thing is, do Pico can store up to 100 MB without SD card storage? You can play MP3 audio, not MP3 but wave lah, WAV wave audio, and stream audio on Pico W. Yes, you can, but you need an SD card because audio files are big lah. The size of audio files are big. So the Pico W itself doesn't have a huge flash storage. You can't save a lot of stuff, and definitely you can't save up to 100 MB of items inside your without an SD card. So you still need an SD card. The Pico W has a flash storage of up to 2 MB, but then normally you won't go up to 2 MB, and we only recommend you to use less than 500 KB lah. Okay. So if you want to save simple codes, programs, then okay, you can save it in there. It won't take a lot of space. Okay. All right. Next, I'm going to share with you on how we should save our code. Okay. Given that we have already done our first project, let's save our code now. So to save your code, go ahead and click File and then Save. Okay, and when you click Save, it will ask you, you want to save it on your computer or you want to save it on CircuitPython device. What does this mean?
Whether you want to save it into your own computer or into
CircuitPython. Yeah. So it's either or. You want to save in a Raspberry Pi or you want to save on your computer. Okay. Normally for us, we prefer to save it. You prefer to save it?
In my own computer.
Oh, in your own computer. I prefer to save it on the CircuitPython device. Okay, because I switch different computers all the time, so I want my code to come with me with my EDU PICO device. So let's say if I click CircuitPython device, the device is busy, I need to stop my code. Okay, stop your code first, then you save. Okay, click CircuitPython. And then it's gonna ask you, okay, save with what name? Just give it a name. Button.py. .py means it's .py.python format.
Is it compulsory to save it .py?
If you don't put .py, it's gonna ask you to use .py anyway. Okay, so when you save a Python code, it's compulsory to have a .py format. Okay, or else it's just a file that you're not saving with a format. Okay, then you click OK. By doing this, you save the code inside your device. So when you unplug it and then you go and use a different computer, you can still access to your file. Okay. So that is saving your file on your CircuitPython drive. If you want to save on your computer, just pick normal computer and then you can save it. From my point of view, one of the advantage of saving on your Pico W is when you have a classroom of 40 students, and then inside your computer lab, you only have 40 computers, and then your school got so many classes. So students come in the classroom, and then the next batch of students come in, and people keep coming in and out, right? So inside your PC, your desktop, you will see more and more folder of your student name when they save the code inside your computer. So some schools, they introduce like, okay, get your own pen drive, save your code inside a pen drive so you won't lost it. For Pico W, instead of getting a pen drive, the Pico W is your pen drive. Use it as a pen drive to save your code. Okay, so that's the advantage that I see, that you can use your Pico W to save simple codes without getting a pen drive. All right, moving on. We are only at button. Okay, we don't have much time anyway. So let's move on to the next part, buzzer. And this time, I'm not going to type the code because it's taking me too much time. Instead, I am going to open the file that I've already saved in my CircuitPython. So imagine you are teaching this in your classroom, and then your student is there waiting for you to type the code. Right? You don't want to do that. And then you don't want to go through your folder in your computer, like, hey, find where is the file. So what you can do is save all your code inside If you don't have the code, you can get it from us. It's in the resource hub too. You just download all the code and put it inside your CircuitPython drive. So what I should do is click open, click CircuitPython drive, go to chapters. Okay, this is my folder. I open chapters, and then I just search for the chapter buzzer. Okay, I didn't put it nicely into chapter, but okay, buzzer module. So I just double click on this. This is my code already. Senang. I don't have to type. This is for me, not for your students. But you want them to practice, of course. Today, I want to demonstrate to you fast, simple. So I save it in here. So now I'm here. I just need to click play lah. Play. Can you hear? So in this project, I think can good. Link join, okay. Very loud lah. Okay, I think I'm gonna mute it first. In this project, we declare the buzzer pin 21 because the pin that is on top of the EDU PICO is already connected to pin 21 over here. This is the buzzer and it's already connected to pin 21. I never on this like that, huh? Pin 21 over here. So this is the buzzer, built-in buzzer. And then if I flip the switch down, it will buzz on the buzzer. Okay.
You can also use your headphone.
Yes, you can also use your earphones, your headset, or your speaker for this audio jack. Okay, you just need to flip the switch up or flip the switch down. Okay. All right. I need to stop using the camera because it's a bit laggy. So sorry about that. Okay, so this is the code lah. The while true means it will forever run these two pieces of code. The buzzer that is connected to pin 21 will buzz at a frequency at 440 Hertz for 1 second. And then it will stop for 2 seconds. So buzz, stop 2 seconds, buzz, stop 2 seconds. Okay. Okay. All right. So I'm going to move forward. So now we have already done the first activity and second activity, 2 components done. We're going to move straight to the comic session, but then we are not going to do this project. We are going to do more interesting project later on.
Oh, okay.
We have more interesting project at the back. Okay, okay. All right. Let's move on to the next topic. I'm going to click new. And then let's go through the comic. I'm going to tell you a very simple story. Okay, bear with us. I'm going to stop my screen. This comic is about water drinking reminder. Okay, water drinking reminder. The SDG is SDG 3. Okay, good health and well-being. How do you promote good health and well-being among your classroom for your students? When we build the project, you tell your students like, hey, what project are you going to build? Instantly, the first reaction is that they will think of what cool stuff they can build. Normally, that's the case. Oh, okay. Okay. So yeah, so what we are gonna do is this comic over here. It's about water drinking reminder, parked under SDG 3, good health and well-being. When we build a project for students, the first reaction is that they want to build cool projects, but then the correct direction is actually to think about the people around them. How can they help people? Okay, with the components that they have learned, button and buzzer, can you help people around you? So this is what the story is about. It started off with, hey Adam, it seems like you need a glass of water. And then Adam is very stubborn. Adam says, no, I'm not thirsty. I drink enough water. And then Mia come and say, hey, dehydration can make you feel tired. You know? Then he still don't feel that it's a problem. So that's where the problem comes in. Okay, the friends decided, okay, this is a problem because Adam is stubborn. He doesn't want to listen to us. Let's build something to help him be aware of his dehydration problem. So Mia and Anna decided to work on a project together. Okay, they say, hey, I know how to use EDU PICO. I know how to program Python, and I know how to use button and buzzer already. Why not we build something, reminder, a notification for Adam. Okay, and this device is simple to be used, just a click of a button. So that's what they did. They built the project together, and they built a coaster for a water bottle. So they pretend that, okay, we are building a project and we need someone to help test out this project. So they give it to Adam, and then Adam, okay, I'll test lah. So as he left the bottle on the coaster. After a while, the buzzer start to buzz. Hey, drink water. So Adam go and drink water. The next day when he come back to school, he feel different. Right? He feel more refreshed, without knowing that he needed to drink more water. And that indirectly solves Adam's problem. So this comic gives that idea of why you should build a project. Okay, not because it's cool, not because you think the person wants it, but because the person has a problem that you need to solve. Okay, that's the purpose of the comic. On page 40, it's about water drinking reminder related to the comic that I've just shared.
Okay.
Yeah, and then it tells you the expectation. When you press button A, it starts a countdown. After the countdown, the buzzer will start to buzz. Press button B, and then the countdown, the buzzer stops buzzing. Simple, right? Then the code is over here on the right side.
Very panjang.
Okay lah, 36 lines. The shortest of them all, shortest. Okay, so every project comes with the code and of course the explanation. We're not gonna do this. Again, I'll save up more interesting project for you guys. I hope you all understand like the intention of the comic. Okay, it's to encourage students to understand SDG and to understand what project they need to build. Okay.
Hai, selamat petang cikgu-cikgu.
Awak, selamat petang. Okay, again, we are open to questions. It's like a storytelling thing lah, but then we are happy to answer your questions too. So keep the questions coming in. Next, we are going to move into chapter 3, page number 47, where we will learn about OLED. OLED. What is OLED?
For me, it's a mini TV.
A mini TV, but then the TV at home is also OLED kan?
Oh.
Giant TV also. OLED. The word LED, you know, right? LED. The word behind the O, LED.
No, I didn't
So
know.
it's like a type of lampu that has a very clear light.
Okay.
So we have LCD, liquid crystal display, and then we have OLED. It's a different technology that allows you to show characters, show words on the screen. So recently, like everyone buy TV, right? They pilih OLED and I don't think they prefer like LED anymore. So last time we have like the big monitor, cathode ray display, or the very big one, then become LED, the thin one, and then now we have OLED, even thinner, like photo frame thin. Yeah. So We have an OLED on the
Very
EDU
small
PICO.
one.
Not very small.
Not very
Okay,
small.
decent
Okay
small,
lah.
decent size.
Can see.
We are going to learn how to program this OLED right now, and
Okay.
we are going to show simple word on it. We are going to print Hello EDU PICO on top of the OLED. Okay, this is one of the attractive project because students can see what's happening on the EDU PICO. It's output, not input anymore. So how long is the code? Oh, 11 line.
Just copy this.
Okay, let's just copy paste. Okay, to help you save time so that you can see more project. So just go ahead, same thing. We come back to our Tony IDE here. Again, I save all my code ready. And for teachers, I think you want this as well. Open, click CircuitPython. Oh, I need to stop my code first. Stop. Click open. Click CircuitPython device. And then inside my folder, I save a folder inside my CircuitPython. I got my code for OLED module. All these codes are open for everyone. Okay, you can download it. It's inside the resource hub. So I have my 11 lines of code here. Done. Okay. The intention is to let the student copy the code. But if they find out that they can also copy and paste like this, it's totally fine. Because the next part is that they need to go and edit the code lah. Tukar the code because their name is not EDU PICO. They have their own name also. They can change the code. So click play. Okay, GP5 in use.
This one happened, Adrian.
Okay, whenever you see GP5 in use, it means that the code previously is being taken up the pin ready. So how do we solve that?
Restart.
Right. We can do a very quick restart. Restarting is the fastest fix. Right. But then in the future, not in the future, in the reason model, right, we solve the problem. You don't even need to do any restart already. You directly don't have that kind of problem. Okay. I do a quick restart and then I play the code. And now the results is on my EDU PICO. Let me show you. Zoom.
Okay, like this one.
So can someone show the OLED? Yes. Come.
Of course.
Must show.
I think FPS too.
Okay. You see the thing like zing like that. That's anti-aliasing lah. The frequency that match. But then in my eye, it's okay lah. Okay. Hello EDU PICO.
You can also put your name.
You can also write your name. Do you want to try?
Yeah, I want to try.
Come. Let me pass you the keyboard. Can watch YouTube on that OLED? Oh, cannot. But you can print characters lah. You can print like logos. You can print your name. You can print bitmap icons. This OLED comes with two colors only. Comes with this white color background or black color font. Okay, it's not the TV kind of OLED where you have a lot of colors that you can print and watch show lah. Not that kind of OLED lah. This is more for information, so you can print out your values from the sensors easily. You can directly see it here. Okay. So Ifa edited the code, and then now it's. Let me zoom even nearer so you can see. Oh, this is the nearest. Can you all see? Hello, Ramabai. Is that the person's name? Can someone show the OLED? Yes. Yeah. Hello, Ramabai. Your name is here. You have been featured. Okay. So this is the OLED. A lot of things you can play with. You can teach students about X and Y axis. You can teach students about how to control the colors, how to invert colors, and so on lah. Okay, so in page 48, 49, it explains to you the code, the lines of codes that you can use to control your OLED lah. You took a screenshot. All right. So after you finish this OLED, the mini activity asks you, oh, can you input your name? Can you put your name in? And also, can you type your name and then print on top of the OLED immediately? Right. That's the challenges. And then inside the mini activity in the book, it also gives you a short snippet of code for you to copy and paste inside your existing code. So you don't feel like, hey, you give me a challenge, but then you don't give me some hint. So this is the hint. Okay. For teachers, if you think the hint difficult, go to the resource hub, download the code like I did over here. I have all the codes here. Okay. All right. We're gonna move on to the next sensor. Still same chapter, chapter 3. Gesture sensor, one of the key sensors, the very interesting sensors on the EDU PICO, gesture sensor. So next we're going to open a new file. Wait, not open a new file. I'm just going to open my folder. Open my folder and select gesture sensor module. The gesture sensor module has a code of up to 18 lines. So what the code does is,
when we do gesture, and then it will print out the output on the shelf.
Yeah. So we have our EDU PICO here. Let's say we move our hand. This is a gesture, right? We move up, down, left, right. Then if you just like that, move up, then it will show us, oh, you're moving up, down, left, right.
Okay.
You
But
wanna
where
try?
is the gesture sensor?
Where is the gesture sensor? The gesture
Here, right?
sensor is here with a lot of labels at the bottom. You see proximity, light, gesture, color. Let me zoom in for you to see.
Very small one.
It's a very tiny little sensor, but a very powerful sensor. Okay. Again, this is a wordy component to show. This sensor over here, it's called the APDS9960 sensor. It comes with built-in gesture sensor, color sensor, light sensor, and proximity sensor, all in one. Okay, but now we are going to do gesture sensor first. Gesture. When we move our hand like that, it will know left, right, up, and down. Okay, let's program it, and then Ifa will do a demonstration.
Yes, Madam Hadiza. It's very interesting.
Yes. There are a lot of applications you can do, right, with this. Okay, let's quickly run the code first, and then you can see the effect immediately. Okay, if I move right, okay, and then you see the answer right immediately. Okay, let me close this. Right. Left. Up. You see us in a very small screen, but you see Ifa's hands like moving like Tai Chi, up, down, left, right.
Tai Chi.
Oh, what happened? Yeah, can you see? Oh, Ifa, you can't see your face. Left, and then you go up, down, up, right. Okay. All right. So that is the gesture sensor, the introduction to gesture sensor for you to be able to experience the gesture sensor firsthand. There is no actual application yet when you experience the sensor. It's just to let the student feel how this sensor works. And once they understand how the sensor works, they can integrate it into their project. They can be creative, they can do whatever they want. Okay, one of the examples that we did in our YouTube channel, you can go to our Cytron YouTube channel. We have this latest video. We use gesture to control music.
Oh, music, yes.
Music. Like you move left, you change to the previous music. You move right, you change to the next music. You move up, it will go volume up. You go down and you go volume down. Do check it out, the video with the tutorial on teach you how to do it. Berapa jauh sensor ni dapat detect?
1 to 2 cm.
Nah, sini
1 ke 3 cm.
3 cm, betul. Okay, 1 to 3 cm. So tak boleh terlalu jauh lah. Okay, and then because it's using infrared, certain how to say, non-reflective surfaces it may not detect so easily lah. Contohnya if you pakai cloth, black cloth, or if you use non-reflective surfaces, it may not be able to detect accurately.
Okay, sebab dia ada IR sensor.
Yeah, sebab IR sensor. Okay.
Okay. Let's move on.
Alright. Next, we have like total 7 comics. Today I can't go through all 7 comics. So I hope you got the book. Go through it. And then, but we are gonna go through the next project, gesture reaction game. Okay, this is a mini game.
This one is my favorite.
Oh, this one is Ifa's favorite. Maybe you can tell us about the comic story without going through the comic. Like, why do we need gesture reaction game?
Okay, so the story is that this girl had a little bit of hearing problem, but she didn't feel like that is the problem. So Adam and Mia wants to help her using this game, and then when she can test her
hearing
yes, during just gesture. If the buzzer the buzzer will
they will play the do re mi
fa, and then she needs to do a gesture, and then it will test.
Yeah, it will test the
hearing.
Yes. Okay, so we are gonna upload the code. The code is like what? 68 lines. Okay, good for typing practice, but then not good for webinar lah. I'm gonna go straight to my Tony here, and then click open. Wait, before I do that, I need to stop my code. Click open, CircuitPython chapter, and then pilih project apa nama? Project sharing reaction game. So this is actually to bring awareness to our hearing losses. Sometimes we play music on our earphone or too loud, and then the music industry or the earphone industry, they don't tell you what is good and what is bad for your ear lah. The purpose of this project under SDG SDG 3, same SDG 3 for good health and well-being, to make you aware of your own hearing health. Okay, understand your hearing health so that you don't destroy your eardrum before you grow old. Okay, so click play button. I have my code here, all the way 68 lines. Okay, don't worry about the difficulty of the code. The intention of all this code are for the students to copy and paste.
Just understand how it works.
So I've done playing the code already. The code is already in EDU PICO. Switch the screen to EDU PICO. So how the game works is, I'm gonna put it here. There are 2 buttons.
2 buttons.
Button A, it's to play do re mi fa tone. You all know what is do re mi fa, right? These 4 tones sounds different. Do re mi fa. Okay, I press again. I hope we can hear it. Do, re, mi, fa. And when I press the button B, I will play the game. And then the game, it will give me a random, the game will give me a random tone. So what do you think? This is do, re, mi, or fa?
I think do.
Do. So do, if you refer to the book,
Right.
do means you go up. Oh, do wrong.
I got a hearing problem.
It's just a recognition problem to recognize the tone. So down, just now the tone is re. So if I play again, do, re, mi, fa. This is fa, right? Do, re, mi, fa. Fa is right. Okay. So this is how you play the game. And then as you go through the game, you get more right or more wrong, you slowly record down and you'll be able to give yourself a score. How many you get it right, how many you get it wrong. Okay, is your hearing healthy or not? Are you able to recognize tone well enough? Okay. All right, so this is gesture reaction game, a mini activity for students to play. Okay, I think we are lagging. Okay, let's move on to chapter 4. But before we move into this, how's everyone doing? Any question? All good, everyone? Everyone? All good? Okay. Now we still have time. Let's continue with the next one, RGB LEDs. RGB LEDs is one of the attractive components as well, but for the younger age, they see LEDs like, wow, rainbow, wow, colorful, shock. And the code also shock because it's only 11 lines. Okay. The intention is again not to intimidate the students with long text-based code, short enough for them to get started, for them to have the confidence to type the code. So over here, I'm going to stop my code from the previous project, click open, and then straight go to the code. Okay. So the code here have 11 lines. I'm going to play my code. So what's the expectation here, Ifa? What's supposed to happen now?
The expectation here is that we can see the color from the RGB LED, RGB stick.
Okay.
And then it will
From the
RGB
RGB
for 1 second.
RGB is here, right?
Yep.
And then it's going to
Has color and then time slip, no color.
time slip. Time slip is to like
1 second.
wait for 1 second and then on the lights, off the lights.
For 1 second.
Let's play the code right now. Okay, you can see the lights. What color is that now? From the screen, it looks like purple, but actually from our eyes here, we see blue. Okay.
Why is blue?
Why is blue? In the code, you see pixels.fill 00255.
Okay.
That actually means red, green, and blue. So blue is 255, red is 0, green is 0. Okay.
000 is
000 is black color. It means no color.
no color.
No color. Okay. If all 255, 255, 255, then you will get a white color. You mix all three together.
Oh.
Okay. And then in here we initialize 5 number pixels. 1, 2, 3, 4, 5. And then these pixels are connected to board number 14. 14. And then the brightness is 0.2% only, 20%. If you put like 1, it will be super bright. Let's try. Okay. It's very bright right now. Very, very bright. So this is 100% brightness. Okay, so this is RGB for you to play around and mix different colors. Simple. I hope this is
Introduction.
simple. The next one will be more fun. All right, it involves our first accessories. Okay, we are going to use the same sensor here, the APDS 9960 sensor for color detection. Okay, let's focus on the code. I'm going to open up my color detection code. Color detection, color sensor module. The code is about 16 lines. What it does is it detects color. It will know if this is red, if this is green, if this is blue, and so on. There are a few colors that we can try. Okay. We also have this color cards over here. Color cards from the accessories. Okay, there are two sides, right? RGB and then sorry. One moment. One moment. So there are, you can show from there. RGB and then white, purple, and yellow. 6 different colors that we can use. So now we're going to play the code. Okay. And then what's going to happen is you will see that in the code, it's actually showing red, green, blue, and clear. Okay, that means that it's displaying you the color that it's detecting. So right now, which color IFA is showing? Let me change.
I'm showing blue.
You're showing blue.
And then the number, blue is higher.
If she's showing blue color, yeah, the blue color is about 7,000. Okay. And then, yeah, and then the other colors, the number, the value will be lower. The clear means the brightness around that area.
Oh,
yeah. So if you show like red color, and then the red color will be the highest among the green and the blue. Okay. The colors that we printed out as part of the accessories are selected colors. It's the color accuracy when they printed out is accurate for you to do this testing. But if you want to use your other items nearby, you can also do the test as well. Okay. All right. I hope you find this project interesting, because the project after this will be even more fun using the color sensor. Okay, the next project is called the color detection game. What it does is it gives you a random color, and then you have to guess the color. Okay? The comic is related to color blindness, actually, to raise awareness for color blindness. Okay? We may have friends around us with color blindness, but are not aware of themselves having color blindness. So by having this game, it actually promotes awareness. What the game does is it gives you a color, a random color, or it writes down the color on the OLED screen. And then you have to take the color and put it on top of the color sensor. By getting the correct color, it will show you, good job, well done. If no, then try again. So this will promote color blindness. That's the reason of this project. Okay.
But this color blindness test is for information and educational.
Yes, it's for educational, to bring awareness, and then doesn't serve as an actual color blindness test. Once you are aware of it, okay, it's time to go look for professionals. Okay.
Okay, that's right.
All right. So everyone okay so far? We are halfway there, moving into chapter 5 right now. Moving into chapter 5. Everyone okay? Keep the questions coming in. I see a lot of teachers here. And again, thank you for tuning in on a weekday afternoon.
Puasa pula.
Oh, puasa pula. Thank you, everyone. So chapter 5. we have accessory. You see if ready for the accessories ready. In chapter 5, we will learn two components, servo motor and proximity sensor. Let's try with the servo motor first. Okay. Servo motor. I'm gonna stop my code and then open my servo motor code because servo motor, right, about 14 lines. Okay, let's speed things up. Servo motor, 14 lines of code. So what this code does is the servo motor angle, it will change from 0 angle, 45, 90, 135, 180 degrees. It will keep changing, and then it will continuously rotate. Every 2 seconds, it will change one angle. Okay. So to connect your servo motor, we have our servo motor here. Okay, and then we have our horns here. So how do we connect? Just take one of the horn out. I am going to use these tiny little short ones here. And then just plug it on top here. Okay, you can plug it in any direction first until we run the first code. Okay, Ifa, do you want to help connect it?
Okay. Where should we put?
We should connect it on GP6 according to page 87 in the book, GP6. So GP6, yeah, at the most left. So now, done. So what I need to do is just play the code. And then you can see the motor starts moving. As simple as that. Okay, it's moving this direction. Suppose. Okay. So to calibrate your servo motor, what you need to do is at the first angle, it's supposed to point on the right side. So when it goes to the first one, 0 degrees, I will immediately stop the code. Okay, stop the code. And then I just need to take this out. Because I haven't screwed it yet. Okay, it's here. And then plug it in this direction. And then continue to run the code. Follow exactly as the book. 135, 180. Okay, about here. It's about here. Okay, so this is how you get the servo motor working. Stop. All right, what do we need to do next?
Next is proximity sensor.
Proximity sensor. So we're gonna leave the servo here, right? We're not gonna remove it. Proximity sensor, page number 91. So proximity sensor also uses the APDS 9960 sensor, same as the one that we were using earlier over here. So it can detect up to 1 to 5 cm lah, the direction. Okay. The code is only 11 lines. So let's go ahead and type the code. Stop the code. And then, not when I say type, I don't really mean type lah. I mean open the code, 11 code. And then click play. So when I click play over here, I have my import libraries, initialization for proximity as true. And then while true, it will constantly print proximity values at 0.1 seconds per value. So if I move my hand above the sensor, okay. Okay, if you move above, then it will be able to show you the proximity numbers. It will change over here, down here. Okay, but then right now the number is so tiny I can't really see anything. So another way to see clearer is go to view and select plotter. Also, again, this is shown in the book. By using a plotter, we'll be able to plot the signals easier. So if you move the hand up down, you can see. So this is proximity sensor. To measure the distance, okay, you can go up to 5 cm. Okay. Right? All good?
All good.
Okay. So next, I think our numbers, more people coming in. Okay, the next part is the automated waste bin. We are gonna build our own rubbish bin, automated rubbish bin very quickly. We call it trash board, a very cute little trash board. So what's gonna happen is it will open its mouth when we have a proximity detected in front of it, and then it will close its mouth when there's nothing in front. So I'm going to leave the building of the box to Ifa, and then while she's at it, I'm going to help her attach the servo sticks for the servo motor so that we can open up. So this is just one of the projects that we want to show you, like, to make you to make it more, spice things up, make it more interesting. Okay, I'm gonna do the servo motor, and then I think Ifa is very fast. It's already done with the box. The box is built with simple card, like strong enough for you to build a box. There are step-by-step instructions for you to follow on how you can build this trash board. So you don't have to worry about how to do it. The steps are already all there. Okay, and then I'm gonna take this piece. Down here, there's this servo stick that I need to use.
I finished already.
You're done already. That's less than 1 minute. She's been practicing a lot for all the videos, and all the videos are done by Ifa, by the way. Okay, so the servo stick is to strengthen the stick on the servo motor. So when it moves up and down, it will be able to push the head, the cover, the servo motor. So I just need to lock it in. Let me show another view. Servo stick. Macam ni. Okay, done. Servo stick. So it's very strong. So when it opens and then opens the trash board. So next we have Velcros here. Velcros for you to stick on top of your trash board. Okay. I'm gonna stick the loop on top of the servo first, and then Ifa may need to reconnect the wire. Okay. There will be 2 loop on top of the servo this way, and then I'm gonna put 2 hooks on top of the servo first. I'm gonna put it this way so it's easier for you to attach it. Okay, done. Okay, and then if I took out the cable, right? So behind here, there's this tiny little hole. You can just poke it open. See, this is for the cable from the servo motor. So I open up the head, take out that piece, and then connect your servo motor this way. See over there? Just connect it here. I connected correctly? I feel like I connected wrongly.
Right.
Wrong. It's supposed to be on the other side. Sorry. But yeah, you are allowed to remove the Velcro and we stick it lah, and it's fine. So these are the potential. I mean, I didn't really look at the book, but if you do look at the book, you can check out the directions of the servo motor and then attach it at the correct direction on the servo, on the trash board. Oops. Let me just quickly attach it here. By the way, we do provide extra Velcros. So if you really destroy the Velcros, don't worry about it. You have a lot of extras. Okay, I'm done connecting it back here. This way, like that. Okay, I hope it's clear enough. Okay, and then the other wire, just push it out here and pull it out. Okay, and then close the lid. There you have it. Your trash board is ready to use. Are you confident, Ifa, on our trash board?
Let's give it a try.
Let's give it a try. Okay, back to the code. Okay, before we get it to work, we need to program it first. I'm gonna stop my previous code, and now I will need to open up my project for automated waste bin here. Okay, so this code, whenever it detects there's a proximity, it will trigger the servo motor. Okay, I've already run the code. So the next thing that we expect is for the servo motor to trigger. Ta-da! Yay! Then it closes back after 5 seconds. So it's a very simple demo. And then you can throw your rubbish in, and then it closes back. Okay, and it opens and closes. All right, I hope you guys find this interesting. Add a cell phone tape. Where do you recommend?
It doesn't need a sellotape.
That no cellophane tape lah. It's just Velcro. We are using Velcro for the servo motor here. Okay, and then this is just by the weight lah. Okay, the weight of the top. The top is heavy enough to close itself. Yeah. Okay. Right. So trash board for you. Okay. Great. And again, this is one of the attractive exhibits that we actually have whenever we go out to schools. We actually show them like a mini trash board, and then students get very excited looking at,
what's that?
The robot can open the mouth and throw rubbish. This gets students excited, and we hope that you find this exciting too. Building this won't take a lot of time, and certainly the code slightly long, but then again, copy and paste for the application, and then slowly understand the code from the book lah. Okay. All right, I'm gonna stop my code now, and we are going to take a breather. Now moving into chapter 6. We have about 24 minutes left. Okay, I'm very happy everyone is still here with us. And again, if you have more questions later on at the end of the session, we will share you our Telegram group. You can join us. You can come in and ask all kinds of questions. Our engineers are there. I'm there. Ifa is there. And also Cheryl will be there, and I will be there as well. You can drop us a question there. Okay. So next chapter, we are gonna go for chapter 6, but we are gonna straight jump to the challenge.
Okay.
Can we do that?
Okay.
Okay. So chapter 6, we have two components. Every chapter we have two components. Chapter 6, we will learn about sound sensor using PDM microphone. Okay, PDM microphone, it's capable of detecting frequencies. But in our project, we use it to measure decibels, to measure loudness. The story is that in the library, students are always noisy. They don't listen to their librarian. You ask them to quiet and they still talk. So a group of students decided to help the librarian build a system that indicate the noise level in the library using PDM microphone. So this actually is part of the community, sustainable cities and communities where you promote noise, understanding on noise pollution. Okay, you may feel it's quiet, but it may be noisy for other people, right? And then having the awareness is good for the environment, for the surroundings. So we are going to build this project, but instead of just building a noise monitoring system, we are going to use this. Okay, this is a noise meter. We will use this, and then the meter will point like, oh, you're very noisy or not noisy. Okay, and then from very far away, you can see the meter is pointing where. Okay, this is especially good because we can use it not just for noise, we can also use it for temperature, we can also use it for brightness, we can use it for all kinds of sensors because it's a meter. Okay, and then there is no specific label on whether it's what unit, decibel, Celsius. There's no label for this so you can use it for all kinds of application. So what you do is just plug it out like that, okay? And then there's a hole here, just push. So this hole, it's for your servo motor. Okay, a very tiny little hole for your servo motor. Okay, let me show for your servo motor. So you just fit your servo motor in here and then it just help you point. Okay. So before we do the coding, let's divide and conquer. If I'm gonna let you do the accessory and I'm gonna do the code. Okay. And then you will see where we should attach this later on. Okay, let's go. I'm gonna do the code. You will speak. Okay.
The pointer.
Maybe can show the screen. Pointer. Oh yes. So we have this pointer over here. For aesthetic purpose, it looks nicer compared to the previous servo stick. Okay, we can use this. And then screwdriver. So we need to remove the servo stick that we used for the trash board just now. I screw very tight, right? Come, let me help. Okay, the tighter it is, the better so it doesn't come off. Okay, take it out and then
Pointer.
we will change it to the pointer. So remember, you don't have to change the direction of this horn. Once you fix it, it's forever same position already. All the chapters are aligned, meaning you don't need to keep changing the position, don't need to keep testing the position. In chapter 5, we already done that, so you don't have to change it. Just change the pointer. Okay? Right? And then next step, I'll leave it to the car.
Put it like.
Yes, the wire goes through first and then according to the book. It'll be facing, yeah. The cable have to go through. Yes. I think the direction is here to here, right? Right? Yeah. Cable from here. Oh. So the meter will be at the center lah. Meter will be at the center.
Oh.
Okay, I'm already done with the code. My code already started to show servo moving to what direction. Okay. I think while we are while Ifa is fixing the accessories, I see some questions from the chat. Okay, I'm glad Jacob Rama feels that we are returning to schools back in the days. I also have a Cytron-rero PICO board where revision 1.2. Is there any resources for this board that like EDU PICO kit? The EDU PICO resources are open for all for you to explore. The board from MakerPi PICO, very similar, but then the sensors, the components are separate, meaning you may need to go and find individual components. The code may work or may not work, so it's worth a try, lah. But what I can tell you is that the programming, the code and everything are similar, so you don't really need to edit much on the code side. Okay, so now Ifa is ready for the noise meter. Terbalik kah?
Terbalik.
Oh.
Can I change it?
Yes.
Was.
And okay. So now let's check first lah. Terbalik means this side terbalik lah. Like that. Is it like the one you did just now? Okay.
Okay.
So by placing it on the box here, it's meant to work like that.
Make some noise.
Okay. So this is the noise. The card here, you see, there's this card here. It's meant for you to attach it on top like that. And then as you make noise, the servo will move. It will move more to the red side lah. And then if you go quiet, then it will remain at the green. Okay, so this is PDM microphone. This project can see my class if they are not so noisy. Yes, and then you can use LEDs. Right now, the LEDs here, green color. If I talk, if I'm noisy, it will become red also.
If the class too noisy but lambat. Yes.
So there are two options. Boleh tengok lampu, can see the light or can see the meter. And then of course, if the class memang dah already noisy, you can change the threshold.
Oh,
threshold means the limit lah of the noisiness, whether they got exceed the limit or no.
Okay. You can change the threshold.
Yeah, so that's the project for noise monitoring system. Challenge. This is part of the challenge. Okay. Thank you, everyone. So we are done with chapter 6. Again, we are going long shot until chapter 7 and chapter 8. We are down to last 2 chapters, and we are going to go through the components right now so that we have more time to demonstrate other more interesting projects. Okay, so now let's go straight to DC motor. Okay, you do the DC motor connections, and then I'll do the code very quickly. So DC motor, why it's interesting is because Cytron, we have always been doing auto drivers. Okay, and then in this case, EDU PICO here, we have a built-in motor testers here. where you can test your DC motor directly without the need of programming your DC motor.
Oh.
Directly plug in, directly test. Tak perlu program.
Okay, fine. Okay, I have a question
Yes.
I got from question from teacher.
Mhm.
How do you know where to put the red, where to put the black?
Where to put the red and where to put the black wire. Okay, the red and the black wire you can put in different polarity, it's fine. Because the motor will move on different directions only.
Okay.
So there is no really fixed polarity stated on the board or the board lah.
Yes.
It becomes sensitive if you are connecting components like a fan blade. By moving a single direction, you're actually blowing wind. And then by moving the other direction, you're actually drawing wind. So if you attach the DC motor in the wrong direction, then your fan is not blowing, it's just tarik angin lah. It becomes like a ventilator instead. So that's where the polarity becomes important. Okay.
Here.
Okay. Yes.
Right.
So to test, so what Ifa did is she tested the motor directly pressing this button on top of it. I think can't really see. You see these 4 buttons here? These are like 2 directions, front and back direction. By pressing this button, you can test the motor immediately. Tak perlu coding, no need to do coding yet. Okay. And then now, if I go to the code here, so I have a code, and the code will, is this 1A, 1A? Okay, 1M1A, M1B. What the code does is it will change direction, 50% reverse, 25% reverse, stop, 25% forward, 50% forward, stop. Continuously lah, every 2 seconds. So I play my code. Okay, you can see the motor started spinning. And then it will terbalik, tukar direction.
2%, 0.
Yes, and then it will stop. So it will continue this continuously lah. It will do this continuously. So this is DC motor. Okay, let's leave the DC motor there, and then we're gonna proceed to the next part. Relay. Relay is something more interesting actually. One of the interesting parts of our in the EDU PICO lah. Okay, we are going to. So what relay do we really need to connect anything? Just connect this only, right? On the USB port here. Relay is the best thing.
You can also charge your phone right here.
Charge phone depending on the cable, but yes, you can also. So relay, we are using USB relay. So this USB port over here is connected to this relay over here. What it does is we can program this relay to turn on and off any USB devices connected on top here. Any device, any USB device. When you connect here, you can control on and off. So let's say if I want to program, let's do something more interesting.
Smart classroom.
Let's do smart classroom. Smart classroom is the chapter 7 project. What it does is it detects the gesture, number of participants inside the classroom. Okay. Example, right now I have it here. If a student walks in a classroom, if a student walk in, this is, let's say the student walk in the classroom. Okay, and then it will use a gesture sensor over here. Okay. Then the light will turn on. Means got 1 student walk in the classroom. So now it's 2 students. Okay, and then 3 students. And then if no students, then the light will turn off. turn on, turn off. Okay, turn on, turn on, turn off. Okay, the DC motor, supposedly M1B or M1A, 20% speed. We need to initialize now. Video getting stuck. No. Hello everyone, are you okay? Still with us? Okay, let me do a very quick demonstration again. This is Chapter 7 project, Smart Classroom. If a student walk in, walk out using the gesture sensor, it will turn on and off the lights. Off light, on light, off lights, on light. Okay, using this gesture sensor over here. Okay, turn off. Okay. All right. I think we don't have much time left. I'm gonna do our last demonstration, very last demonstration, which is about Internet of Things, IoT. On the EDU PICO Raspberry Pi PICO W, there's actually a Wi-Fi module that you can use to control your EDU PICO using your phone lah. You can connect to your phone. Okay, there you don't need to add extra stuff on this. You just need a phone and then your EDU PICO set. Okay. Again, I apologize for needing to skip chapter 8, the whole chapter 8, but then this is part of chapter 7 bonus to teach you Internet of Things. Okay. The reason why we do this, we are using access point, making the Raspberry Pi Pico into access point, meaning you tak perlu Wi-Fi, you don't need internet. You turn your Raspberry Pi Pico W into a Wi-Fi. You use it as a Wi-Fi lah. Then you connect your phone to your Raspberry Pi Pico W. So the code is actually not complex. Okay, I can tell you it's not very complex. Let's take a look here. Okay, I understand everyone preparing to almost time's up already. Okay. So over here, this code, when I run this code, it will give me a IP address listening on this. So what I need to do is I just go to my phone Wi-Fi. Over here, let me quickly show. Okay, my phone over here, click Wi-Fi, open my Wi-Fi. Okay. Again, this is meant for everyone. Click EDU PICO, connected to EDU PICO. Okay, this is the AP Wi-Fi. And then I will just go straight to the address 192.168.4.1. So over here, so this is the HTML, the website that we coded here. A very simple short website. USB relay light control. Can you share the code for access point without password? Technically you can, but then not recommended if you have a lot of access point with different SSID lah. In this case, I have a password. You can leave it empty as well, and then just directly connect. Possible as well. So if I click on, okay, my light is gonna send a signal over to my Raspberry Pi Pico. Okay, hold on. Let me reconnect this. Okay. Okay, but thanks for the suggestion, Ramabai. We are gonna test it out later on, and then join our Telegram group later, and then we will let you know what's the results are from our end. Okay, I think I'm running out of time. Anyway, this Raspberry Pi access point with relay, we will show you the video as well inside the resource hub. But the intention is that you connect it to your Raspberry Pi Pico W. Okay, you connect it to your Raspberry Pi Pico W, and then you can control it on the web page to your relay directly. Okay, that's the whole idea. All right. I think I'm gonna wrap up from here because we're about the overtime already. 3 more minutes left. So in this the whole EDU PICO, the last two sensors that we didn't cover is actually humidity and temperature sensor, and also light sensor. That's for you to build greenhouse. Okay. Okay, so we have covered, I think, about 80% of everything else, and then hopefully we can cover the remaining one at our resource hub. We will share the link in the website, in the comment section right now. And if you are interested in, want to know more about EDU PICO on how you can introduce this in your classroom, please join our Telegram group here. We will drop the link in the chat as well, right? Okay, and then I see a lot of questions coming in. That's great. I'm gonna try to answer all the questions right now. Can control other functions beside the relay, like the OLED? Can control other functions beside the relay, like the OLED? So the OLED is built in with the EDU PICO. You can directly program the OLED, control the OLED. The relay is connected to the USB port only. So if you program the relay, you control the USB port. If you program the relay, it's just for the relay. Okay. I hope I answered your question, J-Law. If no, please join this Telegram group and then we can continue our conversation there. From Rama Bai, I use access point and it works good, but too many exception handling. It's true. There's a lot of background exception handling. But we'll see how we can improve that. Okay, do we have more questions? Guys, keep the question coming. We will still be here. Okay, we have another one. Perlu ada internet kalau sambung ke Raspberry Pi? So, yes and no. Kalau guna access point, if you use the access point, tak perlu internet. You only need the Raspberry Pi Pico. It will become the Wi-Fi lah. So actually, it's offline. Offline lagi, just like you want to show the concept of Internet of Things. It's a bit similar to Bluetooth lah. You don't really need internet. You just form the connection. In Chapter 8 bonus, we have one activity that allows you to connect to internet. And that one, yes, we need internet. So ada dua option lah, with internet and without internet. Chapter 7, no need. Chapter 8. Okay, I hope I answer your question. Do give it a try. Okay, any other more questions? All right, searching for resources to integrate audio in Pico, but too little resources available. We are working on getting more and more resources out. But recently we just posted one of the MP3 one. We have more coming up. Like one of these new ones that we have is actually not released yet, but then how to connect your EDU PICO with battery pack. Okay, over here we are using the 6 volt, 3.7 volt battery, little battery, and then this is actually not connected to the PC lah. I think our screen is a bit small, but we will see the video coming out very soon.
Okay, thank you, Adrian. So teachers, if you have any further questions, please feel free to join Telegram support group. We are there to support you all the way. And info for everyone, if you are interested to get the kit for yourself, you can actually get it now at 20% launching promo. I think there are another 6 days left, so make sure you get it. And the stock level now is 19 only. So make sure you grab this batch, else you will need to wait for the second batch. Okay. So for teachers, okay, this is the link for SPLKPM. So this is only for MOE teachers. Okay. So this is for MOE Malaysian teachers only. This is for the professional development record. Please fill up the Google form. We will also share the link in the chat. My colleague will post the link in the chat. Please make sure you fill it in, submit in this 1 hour, okay? And JPN Johor officer will help to record it in SPLKPM. Okay. As for non-MOE teachers, if you are joining us from Singapore, from Indonesia, or if you are from a private learning center, scan this QR code. This is the attendance and feedback form for non-MOE teachers. Okay, the link is in the live chat. You can click, and again, make sure you submit in this 1 hour. We will close the form promptly. Okay. So these are the 2 QR codes if you need. And while you're doing that, let's see if there are any other questions that we need to address. Okay. I think we have pretty much covered everything, right? Let me just scroll through. Let's go through some feedback. Okay, this is for the team. Thank you for collecting Cytron boxes. Thanks for loving this board. I think Adrian will be very pleased. And yes, good job to Adrian and Ifa. Good job. We thoroughly enjoyed the session. Love the comics. Very positive feedback. Yep. Anything else? Yes, this teacher mentioned, Adrian, that this kit is really good for project-based learning. And I'll have to say that I totally agree with this. And good job to Cikgu Haliza. Love your learning spirit. Any more that I miss? I think that's all. Okay, so before we end the session, any special message or anything that you like to share with the viewers who are with us this afternoon? Adrian or Ifa, any thoughts or any kata-kata semangat, especially for teachers who are new to coding or new to Python programming, or just graduating from block programming to text-based programming? Any tips that you'd like to share with our teachers?
For this is just from my view lah. For teachers who are moving into text-based programming, my word is that don't feel fear of text. Take it as it is. Slowly, gradually build confidence, because we don't get confidence in a single day lah. Okay. The intention of having EDU PICO is to help you build confidence through copy and paste. Okay, through copy and paste, and then eventually, once you copy and paste enough, you will slowly get to understand what the code is about, understanding the code. So don't worry about memorizing a lot of code immediately, becoming an expert in a day. We will slowly get there with some practice, and I hope that EDU PICO will be there to help you practice to get where you want to be. Okay. This is from me.
Yeah, that's all.
Okay, so once again, thank you very much, Adrian. Thank you, Ifa, for the wonderful sharing. We thoroughly enjoyed the session and love it, having this first-hand experience with EDU PICO. So here, on behalf of Cytron Technologies, we would like to extend our appreciation to JPN Johor for the collaboration, for bringing this webinar to teachers, trainers, and also students who join us this afternoon. So with that, I'd like to apologize for any shortcomings on our part, and we hope that all our viewers will have a wonderful time exploring and learning Python programming and physical computing with EDU PICO. That's it from me and our team. Bye bye. See you.
Bye-bye.
Bye.
Thank you. Bye.